Well, hello. I'm Steve Smith. I'm going to be the host for this workshop. I decided that it would be a shame to let the remaining 3 minutes before we really start go to waste. And so I'll say a few words about why we're having the workshop, what we hope to accomplish, and maybe it'll set the context for the work that we do today. And I hope we do some work. Um, so the subtitle is Time, Uncertainty, and Visual Positioning Support. And that's a little odd that it's this jumble of different terms that don't seem related. And in fact, that's the theme of what we're doing here is that we're looking at the pieces of standardized data objects that are required or useful in the context of making a request to a visual positioning service and getting a response back. And the visual positioning service, if you're not familiar with that, is simply it's something that if you show it an image, it'll tell you where that image was collected and the orientation of the device that did the collection of the image, the camera or other kind of a sensor. It has been a cooperative venture between the Metaverse Standards Forum, um, especially the real and virtual integration domain working group and the OGC to share the work of discovering needed standards and for doing the work of creating a standard. So in the Metaverse Standards Forum, we've uncovered a lot of requirements and needs, and in OGC, we've started at least the work of providing the framework for support. So it's time now to officially start the workshop. Welcome, everyone. Good morning, good afternoon, good really late at night. It's a joint workshop of the Metaverse Standards Forum and the Open Geospatial Consortium. Metaverse Standards Forum is a huge collection of industry participants focused on the metaverse, things that live in the metaverse, things that you can sell in the metaverse, how do you structure the metaverse. But it's focused on the topics and the requirements, and it's not a standards development organization. And in this work, we're working with the Open Geospatial Consortium, in particular the GeoPose Standards Working Group, to take some of the requirements coming out of the Metaverse Standards Forum and turn them into standards. So today we'll be going from a discussion of, well, an exposition really of what visual positioning is and how it works and what the requirements are for communicating between different parts of the architecture. And as we work through at the very end, then we'll get to, and these are the standardizable objects which can be used to communicate within an architecture for visual positioning that the OGC, GeoPose Standards Working Group, is actually developing. So what's a GeoPose? A GeoPose is just a location and an orientation. It's like if you want to describe where a camera was when it was taking a picture, that's a pose. And if it's tied to geographic coordinates, it's a geopose. So the agenda for today is to look at visual positioning as a core use case for GeoPose. And GeoPose has evolved to be a family of components, and we'll really be talking about the individual components and how they can be composed together to support visual positioning. So we'll get a lot of context about visual positioning and sort of what it is, how it works, some prototypes, and then look in detail at the support that we're putting into updated versions of OGC GeoPose. Now, Simon Jackson will take it away.
Actually, I'm going to start.
Okay.
Thank you, Steve. Good introduction. Thanks, everybody. Welcome to this joint webinar. It's really exciting to be here. It's not a webinar, it's a workshop. Um, my role right now is to introduce to you the industry association that that I helped to start a decade ago. Um, and it's the AR for Enterprise Alliance, which we call the area. It's an industry association funded by its members, and it is a global industry association. We have members all over the world, and our goal is to accelerate the adoption of enterprise AR. And it takes a village, it takes an ecosystem for that to happen. So that's why we have four strategic pillars. One is around providing thought leadership. Oops, sorry, could you go back the slide previously, Steve? One is to provide thought leadership, and that's in many forms. We have white papers, a lot of materials on the web. It's one of the biggest sites about the topic of enterprise augmented reality. We also publish for our members twice a year research reports. And these research reports are strategic. The members themselves decide the topics of those research reports, and we're going to be hearing about the most recent report. That's the one that was done about visual positioning systems. But in addition to research and publishing materials for our ecosystem, we also do support networking and community development, really trying to make sure that the people who are interested in enterprise augmented reality, who are applying it, who are putting it to good use, can find each other and find the right tools and services that they need. We also have campaigns around um, uh, educating the future workforce to work in enterprises where AR is used. And as a whole, all of our committees, like the Requirements Committee, Safety Committee, Security Committee, we're all trying to look at what are the barriers to adoption, to widespread adoption, and then how can we reduce those barriers together? So this is a community, as I said, 10 years. We've celebrated our anniversary about a year ago. And to the next slide, I'll show you our current membership. So you can see that we have a nice balance, really. It represents the ecosystem of companies that are using these technologies on a daily basis. That's the center of the figure. They need, of course, hardware and services. Uh, just below that picture, below the bubble of enterprises. On the left-hand side, these are some of the service providers and software publishers. And then we also have research groups, standards bodies, um, uh, universities, just a variety of different non-commercial entities. So this is how the area is balancing itself and represents a balanced view of enterprise AR. With our member dues, We fund, as I said, two bespoke research projects per year. And in late 2024, the topic that was chosen was visual positioning systems. So I'll now hand it over to Simon Jackson, who was a member of the team that did this research for us. Simon, take it over.
Okay, so hello everyone. I'm Simon Jackson, work at a XR development company and research called Ether, and we're here today to talk about virtual positioning systems and the work that is done on behalf of the area to sort of survey the market, as it were, to see what's out there, what the capabilities are, what is visual positioning, in a way to break it down into terms that are easily understandable. Myself, I've been in sort of the XR, AR, VR industry for almost 2 decades now. It's always shocking when you look back to just how long you've been doing these things, talking, presenting, writing papers and things on all things that there are. And I joined Ether it's almost 5 years ago now, working to try and push the boundaries of what the art of the possible is within the visual positioning space. So, hey, there we go. Where's that going? Okay, so as part of the project that we undertook for the area, we had to look at what was available, what was out there, understanding the state of where the industry is, where it's going, understanding what companies are out there offering services or who are consultants or providing consultancy to deliver projects themselves. But in evaluating what is out there, we then had to come up with a consistent method for how do we validate what all these solutions offer? How do we compare apples to oranges to pears in a common and consistent way to ensure the fact that as we're looking at what these offerings are, how do they stack up against each other? Where do they have benefits, where they have cons, and where the rubber meets the road, and how these kind of solutions can help in the world of trying to position things out there. And then once that methodology was defined, how to then define and benchmark those measures to ensure the fact that there's consistent validation from solution to solution, how they mark it up. This has all been delivered as a report to the area, and including all the benchmark results, and also including, more importantly, the methodology itself. So as any new solution comes on board, or as any firm wants to evaluate how a solution fits in their market, they then have a testing strategy to be able to evaluate and check whether these things work to meet their own needs. So if we look at what this is that where localization and visual spatial positioning and all these different technologies come to play, it's all about how to realize our digital estates and our digital affordances in the physical world. Traditionally, they've always been treated separately. There's either been a 3D CAD system, there's been a drawing that's been put on paper and then be used to place somewhere. But as technology is evolving and how the consumer market now is also being paired with the business market for bringing digital content into a world where someone can realize this, not just I can look at some 3D content on my phone, but here I am standing in this marketplace. What are the things around me? Or if we look at the tourism industry, it's a case of I'm visiting a new city. Where's the cafes and what the reviews are and how they are? How do I find them? How do I get to them? And also, if I'm there, what are the cultural landmarks around benefit me as a consumer? On the business side, the actual tangible results are a lot more real, because you're looking integration with IoT technology to get real-time data from content and storage and systems that are in place in the service, providing more visual recognition of, as I'm standing in this warehouse or in this hospital, what are the devices, what are their health, what was the information telling me while I'm in place, not just remote where it's working out. And all of this needs to be complementary because it needs to know where it is, what the state of it is, what it potentially looks like, and also how to accurately place it within the real world in a stabilized way, so that if I'm moving out rather a hand holding device or a head one device or some other kind of sensor, to ensure that we're accurately mapping these things together. So what it comes down to is that we break down to what do we mean when we're talking about actual visual positioning, or VPS as we tend to refer to it. Ultimately, it's a case of I want to identify where I am in the world, where the device I'm holding or wearing, where it is, not just where it is in the world, but where is it in relation to a building or in relation to something that it can see. Once I understand where I am, I need to then align the device to between what is can be seen physically in the world to what's known about it digitally in respect to where it is, mapping up the physical and digital almost as a digital twin being realized in the space that I'm walking in. Whether or not as I'm walking into the entrance of a building, are the visual posters being put up? Am I putting up some kind of character or person up in there to actually give information to the user as they're entering a building, or as I'm navigating through the space, am I finding information? That then relates to the case of that once I know where I am, where I know where I can match to it digitally, is how can I then place additional information or content relative to that person as they're navigating through the space, whether it's as a one-time act of I'm scanning something and something appears, or as I'm navigating and walking through a space, what information is being presented to me and making the real world enhanced by the digital and truly augmenting the space. Now, there are requirements to any kind of visual positioning system. Generally speaking, you need to have some kind of pre-scanned space. The space, the physical space that is there needs to be recognized, needs to be captured, needs to be stored, whether it's through one of the various techniques, which we'll come on to in a bit, to actually then have the digital mapping of the space so that the device understands when it's in the space, it can see the space, it can recognize where it is. Traditionally, in the case of this also then requires a camera, can be improved with some kind of sensor device like a LiDAR device or the depth sensor or some kind of other sensing technology. But ultimately, in the case of the device needs to be able to see where it is. From that, it then needs to make sure the fact that it can be localized within the space. There's usually some kind of internet connectivity required or some kind of embedding on the device so it can actually understand what it's seeing, map to what has been pre-scanned to relatively place where it is. And ultimately, the one thing we can't get away from, and the one mandatory requirement for this, is that we need light. It's not going to work in a darkened space. It's not going to work in a room where there is no light or any way to sense it. There have been research and things been done which trying to use infrared tracking systems themselves. But traditionally speaking, you need daylight or natural light or some kind of artificial light in the space to light it up so the device can see it as it's being operated. As we break this out, you can see how these mapping systems work together between the map space, whether it's using a point cloud, as shown on the left here, where we're actually using the depth sensor to track feature points within the space, capture where they are in 3D relative space depending on where the device was scanned, or we can use photogrammetry or Gaussian splatting techniques where we're actually using images to then generate these feature points and work out a map space. These are then generally processed by some kind of back-end service, correlated and compounded into an actual feature set, and then ultimately then compressed down to a way that can be used by a device at runtime. Ultimately, you want to keep the data set that you're looking for low. So where other systems are usually in place to actually work out where you are in the world, this is the map and the relational systems you want to work at. If the data set is too large, you're putting too much impact onto the individual device when it's in operation. You can try to offload these with cloud services, but then that puts more demand on your connectivity and your services. Again, it all comes down to the use case that you're working with and how that relates to the operation that you're going to be operating in. As we discussed in the virtual positioning systems, there are several levels that we use in this, and ultimately, when it comes to any one solution, you're using a combination of these services to provide finer detail down to where you are. The finest detail is the actual virtual positioning itself, using a high precision mapping from a space. to actually then localize where a device is precisely while it's in operation. Obviously, this needs the space to be pre-mapped, and to also ensure the fact that when you're doing the mapping as well, you're also mapping it in different light conditions. As I stated, light is a critical factor, but obviously when you're scanning these spaces, daylight, midday, dusk, these are different lighting conditions that require different maps to be able to do it. So there's a fairly high level of maintenance involved in keeping those solutions alive. They're also impacted by other environmental factors, some to a higher degree, some to a lesser degree, depending on the solution, but changes in conditions. So if you knock down a wall, a map of a scanned area is not going to be as accurate if you don't then remap it to when the wall is missing. It will work to a degree, but you're lowering the confidence of how that's going to work. To identify what kind of map we're going to be working with, you're usually sort of a wide coverage solution like GPS, so that I know roughly where you are on the world. I know these are the maps I'm going to select on to actually then start the initialization process. This is good for coverage, it's easy to implement, but it doesn't work in areas where there's either low precision, usually indoors, or in areas where GPS is not available. It only works for actual localization. It does not actually work for actually positioning the device to the virtual space. To get this, we can complement these solutions with either kind of marker or image-based AR, where it's a fairly simple setup. It's an image or a marker on the screen. You have instructions on the device to go and scan it. And from that, then you know where in space that device is relative to that marker, provided that that marker is fixed to that pixel space. Traditional image marker solutions, it's a case of that image could be anywhere. So you have to guarantee that this marker or this image is going to be in this space for the scanning to work. So that requires a high level of maintenance to ensure the fact that those markers maintained, they're accurately positioned, and some kind of asset register is recording where those images actually are. So you need to make sure those are maintained and how those solutions work. Now, we've talked a lot about visual systems and how they work, but there is another side to this visual coin, is what we class as spatial anchors. Now, spatial anchors are a different classification of visual positioning, where instead of mapping a digital recreation or a mapped space, we're actually taking an actual specific point in space based upon a physical location. The way this works is a case of you have to go and scan the space, but instead of recording the space, what we're actually recording is a single specific instance within that space, and that becomes our singular anchor. Now, this is good because case of it's a lot more reliable. It's also actively scanned and using an entire space to anchor a specific point, and that's persisted so long as your cloud data and your device data are kept in sync. It also means that shared experiences can be shared a lot easily because you're using a third-party service to actually localize the point, and that point is ratified over the time the device is being used. Although you wouldn't use a single anchor to define any space, you'd use these like breadcrumbs. So you'd actually map several key points so they can actually track position through the actual space and keep the momentum of what you're going around. This is especially good if you're trying to have walkthroughs in spaces to try and keep elements spatially aligned over time, because the further away you get from a singular point, the more drift you incur between those points. So if we're constantly having additional points to actually mark on, improves it. These also help for identifying from like a GeoPose of the space. So a spatial anchor isn't itself a GeoPose. It's a recorded point at a particular pose in a particular view in space and fixed because based upon its surroundings. But again, also like virtual positioning, it's not a magic bullet because you still need to be able to say, right, well, these are the actual spatial anchors I am looking for. So I'm using either a mark or a GPS coordinate to say I'm approaching this building or approaching this space. These are the anchors I'm going to be looking for, because again, it comes down to refining that data set of this is what I'm looking for. This is how am I aligned within the space. So as we turn more to the study itself, We assessed over 30 different providers that are out there, and there's an interesting trend that seems to be going down, mostly because of how the markets play out, or due to market demand, or even awareness of what virtual positioning systems and solutions can provide. So the offerings out there are actually diminishing. Where there used to be good half dozen or more different solutions, a lot of those actual vendors are now taking their solutions in-house and turn more to consultancies with a proprietary system. So the actual public solutions that are out there, while good, there are down to a handful of actual providers out there. And even in that space, some of them have moved away from offering public services where the solutions were available. They're not actively supported. In the study itself, we've focused down to those that have truly been active, including one which was a new addition to the actually within the last few months. As ever, these things kind of move, change. It's always good keep an eye out there. And a lot more kind of these offerings are moving into like specialized consultancies. So they're focusing within the construction industry, or they're working within the healthcare industry to provide value-added services on top of visual positioning. So whether it's a case of asset management, or whether it's service management, or cataloging of services and what they're going to do, or offering consumer-facing services on top of their solutions behind the virtual positioning. So using it as a sort of launch pad for offering additional services which they see more value with. So with this change, those that remain are becoming sort of the market leaders, and they're usually large holders within the space. The likes of Google or Magic Leap and others are creating a carving of, they're refining their offerings and having solutions out there that they do, whether it all having their different focuses in technology, whether it's photogrammetry, or it's Gaussian splatting, or whether it's anchors through spatial positioning. So as we break this down, and what the report's trying to do is we have several key metrics for this evaluation. So how accurate is a solution at actually not just scanning a space, but also maintaining that accuracy while it's running? So how much drift and how much error is prone from actually scanning a space to place it in there? How reliable is it? So how often does it need to relocalize or call back to a service, or to operate on the device while it's running? How resilient is it, so that as people are walking around spaces, or tables introduced, or things change, how much change impacts a solution in its running before you have to do rescanning or change how your operation works? How scalable it is, which is actually, this is one of the areas in the study we found that most of the solutions are almost infinitely scalable because they work on a per device basis. Any sharing or coordination happens at the developer's own behest, what they're doing. So scalability we found was actually quite easy, other than the fact that how many maps or how many scans you can accurately use concurrently. So if I'm walking through a space, can I have the entire building's map running at the same time, or should I just have the singular floor and then change as the floors change, and so on? And then ultimately this comes down to what devices are supported by each platform. A lot of them are focused purely in the handheld space, although this is an area where we're seeing the most change, mainly because the device industry is changing. Every day now we're seeing a new headset or new glasses or some other new technology that's coming up. And so it's a monitoring for how these different vendors are reacting to them. Those that are benefiting the best are relying on standards, whether it's OpenXR or other mechanisms there to proliferate upon to include their support. Standardization in this is becoming a real key, that if you want your platform to be successful, if you want to be more widely adopted, you need standards to be able to drive up all the different devices, especially as the amount that are coming out there today. Out of all the various vendors we do, as I said, we do over 30. I think it was almost even close to 60 out there researching on what are available, who were associated or working in the space of virtual positioning or anchoring, or who offered something, an SDK or something out of the box. but we had to focus and limit ourselves to those core providers out there. So predominantly Google with their AR Core and geospatial offerings, which they made a big announcement a few years ago. They're still maintaining, although their roadmap is a bit more in contention because they don't actively update, but that's Google's intentions. Niantic is certainly one of the biggest leaders out there, especially if they've been in the news, but how they're changing and selling off their game business to focus more on the Niantic sort of world spatial map and how they're working. But they're offering lots of different technical solutions around their devices and what their offerings are. Hexagon, or through Immersal, are providing their spatial mapping services, as well as Onyx, and then the new addition to the party is Multiset, who came out of the next AI space and have really put forward. I mean, their solution impressed me the most, and they're actively developing and moving forward. So they're a new entry to the party, but they do have a lot of interesting things out there. One of the most stable providers, obviously, out there the most is Vuforia, backed by PTC now, where they've got different targets depending on different solutions and how they're working in mobile devices, and they do try to extend their support to as many other devices out there. So these are the 6 providers we focus in on, and out of that we had to ensure the fact that it met the business needs. So we had conducted numerous interviews with lots of different area members and others and other different business members about what they kind of needed from visual positioning, what kind of problems were they facing. So overall, how did these solutions fare in how they worked in a real sense? How much support do they need for both indoor and outdoor solutions? Interestingly, that aware there was a business need for transition or working between the two. Offerings that were provided generally only worked well in one or the other. And so that meant you had to have a competitive solution that worked, transitioned or worked between the two. No one provider provided a true transition from indoor to outdoor or outdoor to indoor because of the complexities involved there. Within as well, it's looking at what kind of lighting mechanisms we've worked with. Did you also support occlusion? So obviously within the digital realm, you have to address and realize that the physical can get in the way. There's no point in drawing a 3D augmented element if there's a wall between you and where this content should be. But obviously that adds to the complexity of the solution and also to drains the performance of the solution, because it means the fact that on the device we need to take account from physical elements which are blocking virtual elements and stopping things from drawing, as well as handling the complexities of map availability. So if I've mapped 16 floors of this big residential space, is that going to impact the device too much when it's in operation to be able to recognize these things, and what mitigation strategies you need to ensure the fact that you're layering maps or transitioning between maps as you're getting closer or further away from spaces that are mapped. By and far, one of the biggest concerns as well was also a content strategy. Now, some of these solutions provided require you to actually embed content within the maps that scanned itself. Now, this gives you a benefit because it's fast. It means there's a single download for how things are mapped and spaced. However, it means that if you change your content, you need to then provide a new map. If your map change, you need to then reposition all your content. Other solutions give you a space and you can map the content separately, which gives you separation, but then you need to ensure the fact that the alignment is done with those maps. It's trade-offs one against the other. And all of it comes down to what your business need is and how that goes. Also, when it comes to complexity, a case of do you actually have the in-house capabilities to manage these solutions, or is it going to be more beneficial to your business to actually look for a consultant who works in this area and can provide these services out of the box? There might be a higher cost for doing this, but it means the fact that you don't need dedicated in-house resources to maintain or observe these things. As with any kind of solution, it's a consideration you can implied. Now, one of the areas where we did highlight as quite a concern in any visual positioning solution is that there's limited support to maintain the solution. Generally, it's down to either user feedback or maintenance inherent within the solution, because if you've not married this with like either building solutions, whether people are going to do maintenance on your building and know in advance it's going to affect your map solutions, or if there's going to be significant changes because a new department has now gone into a space, they're going to change everything else, but you don't know that this is going to affect your other solutions that are actually mapping these things. And there is almost no feedback from mapping solutions themselves to note that a space has, or the mapping within that space has become degraded. So there's a care that needs to go on there. Granted, this is also one of the areas from a standardization perspective, which could really benefit, because if there was a more generic way to inform about the health of a space as that's been mapped, it improves the whole ecosystem end to end. And this is where you need both enterprises to highlight the concerns and make them aware to vendors, so that bodies can then get involved to come together and actually coordinate these areas. As we look at the trends and how this is going forward, it is moving towards more of a cloud-based space or cloud-based operation, trying to offset how much works on device and how much in cloud, so that you can offline manage all these spaces, both from the health perspective, managing content, managing how devices can be downloaded and work, either streamed or on device, to provide a much more fluid space. This is powered by the fact that if you look at the technology trends we see today, the move towards head-to-one devices, while powerful, are providing less power overall, and they themselves are requiring more offload, or a hybrid environment where some processing is done on device and the rest is offloaded to the cloud. We see this with AI, with machine learning, with other kind of image recognition systems, and virtual positioning is no different. In order to accurately position the device, while the glasses themselves or the handheld device itself knows roughly where it is and give a base estimation of what it's looking at and where it's looking down, you need a way to be able to take as much of that and offload it to some other cloud service, so all the heavy lifting is done elsewhere, to keep the devices light, keep the devices powered, because we want these things to last all day, not just for 20 minutes, and provide as much power into the ecosystem. You'll see fragmentation in this because you'll have more powerful devices like the HoloLens and the Magic Leap, and more industrialized sort of in the area where we're seeing with the army, where they need to push things more to a device. But these are seen as more of the less of the concern to the market, and the more wider consumer variety is people want it lighter, they want it smaller, they want it to last all day, they want everything in one go. But within this, we're seeing a lot of fragmentation, and this is where, again, market fragmentation standards have to go hand in hand too, because as the market fragments, we need standards and interoperability to then make sure the fact that you as clients or businesses are not impacted by all these different changes. You want to be able to bring your own device into work and have anyone else bring their headset into the space, or to lower your cost and have a much more range of devices that are supported. Vendors need the support too, because if they're going to support all these devices, they don't want to keep rebuilding their SDKs and their platforms and things to suddenly have to support on the device. They need standards, but this is where both business and standards and the vendors need to come together to agree all these things to get them up front, so that everyone benefits by building the best solution on top of the platforms, rather than trying to keep building these platforms. The other area we've seen a lot of investment and recognition is that visual positioning itself also needs a helping hand when it's working in the space, whether you're using 5G networks and more higher band network access for these devices to be able to get data to them, using things like beacons to actually then better provide more localization strategies, so the headset works less because it knows more where it is, because it's in relation to areas where it knows about, because it can sense these things nearby. There's a lot of advancement to sort of the low power Bluetooth beacons and other positioning technologies to then refine how we work out where the device is and what it's looking at. This is also used in areas of robotics and also in more IoT systems where data is king, because as I'm walking through a space, it doesn't matter whether I'm an end user or some big enterprise, we need more data to be able to afford. Is this place open? Has this sensor overloaded because the temperature's too hot or too cold, or are there doors, emergency doors open and things like this. All critical information that needs to be provided to people at the point of time when they're actually seeing it, not just on an app on an iPad that I need to get out or go back to a control room and look at this information and find it out. Data needs to get more into people's hands or into people's eyes these days for how it's going to do. But also within this, we have to recognize that privacy and security and safety are key and paramount, not just from the data we're sharing, from knowing the position of the data of what person's seeing it, but also the ethical concerns of the information that's being passed back to the end user, no matter their walk of life, whether they're a corporate user or a everyday user. There's certain information that only certain people should be able to see, or more critically these days, especially with GDPR, the data they can opt into to be able to see. So yes, there's all these sales and ads, but I need to be able to restrict those to levels of information that people have actually quoted on or are enabled to see. I see this as sort of a spatial internet these days, because there's all the information out there which we need to aggregate and filter to what's relevant to the person who can see. But then there's additional level of filtering beyond that of what there's the information as the person actually opted to be able to see, whether it's the history of something or whether it's just something is there, or all the information that's related to that. Right. I've preached and talked enough, so we can have a look at what kind of questions have been thrown down here. Derek's been sharing information on GeoPose, and there's one question about a open standard-based protocol for VPS, which, yes, Steve is quite right. Derek is pointing out there's a project already in place within the OpenAI cloud to start the ball rolling. For it to be able to build demand, you need to start with create a starting point for this, how we begin the conversation, and then everyone can sort of build upon that. So say, well, within this visual positioning system in this standardization project, is well, I need this information, or this is the kind of information I can provide, or these are the developments needed to be able to give more information or control around these solutions and what they can do.
Well,
So,
thank you
Steve,
very much, Simon. That was a great presentation, and I think it opens up the context of visual positioning and added details that were new to me as well. So thank you very much. I think in schedule considerations, we should divert any additional questions to the chat, and Simon will pay attention to the chat and answer your questions. So thank you again, Simon. And Tony. So I'll touch briefly on the project within the real virtual integration working or domain group in the Metaverse Standards Forum that generated the requirements that the OGC GeoPose Standards Working Group is considering for new versions of the GeoPose standard. And this is based on the ride-hailing prototype where a car and driver are navigating toward each other. So it's just a phase of ride-hailing between the arrival of a car in the vicinity of the person, the rider, and the person, the walking person and the driving person eventually becoming close enough that they recognize each other and complete the rendezvous. So this was done originally with the idea. So in the background here, I'm showing a capture of two rendezvous that we, you could call it a rehearsal or a scripted replay. We had people with chest-mounted cameras. We had cars with a car with cameras in front and back, a smartphone, a drone flying over the area. All of these different imaging platforms were observing each other, as you can see in this set of 6 synchronized video streams. The upper left is black because it hasn't really gotten to the beginning yet. But the idea was that in order to prototype this ride-hailing rendezvous, we needed, among other things, visual positioning. And we had the opportunity to compare ground truth. In other words, we know from sensors on these different imaging devices, also the orientation and the location of those devices in a frame-by-frame fashion. So it's possible to compare the results of a visual positioning system against this ground truth in order to perform benchmarking. So our idea is to use that, and in a minute we'll have a little description of a benchmarking project to measure the performance and quality of different visual positioning systems, or different prototypes of visual positioning systems. The first one is one that's presented by Gabor Soros of Nokia Bell Labs. This is actually a captured presentation from our previous Metaverse Standards Forum Real Virtual Integration Working Group last week. Gabor is not able to be here today in person, but he's here in video.
This is, I gave it a title, an open visual positioning service, because, I mean, there will be others in the future, hopefully. And this is just a research tool. Don't think, so I just want to lower the expectations a little bit. This is not something that you can use in your products or provide proper services for AR contents. But this is a research tool built on top of other research tools. Okay, maybe start with a little bit of background. So we all know that Niantic released this Pokemon Go game in 2016, and it was a huge hit. But it belongs to this vision that we should have ubiquitous, geographically anchored digital information around us when we have smart glasses in the future on our heads every day. There was even this, I really like this figure on the bottom left about the vision of a spatial internet, where you have these clickable icons showing all the restaurants. And this is from 2018, but if you actually look at the Street View images of Google, this is a photo of the street in front of our office. On the right side, actually Google was already experimenting with these kind of points of interest bubbles back then, and today they already have this Google Geospatial AR SDK where everybody can build these kind of experiences. Also, the creator of the Pokemon Go, this scientist, recently sold all the gaming part and rebranded itself to be a mapping company, creating visual positioning maps of the whole world. So this is there's a lot of interest recently, also in the research community, and we will look into a little bit how these systems work in practice. So if you want to anchor digital contents to a physical location, you need to basically recognize very precisely where you were before. And this is usually done with something called an AR cloud. There are many different AR clouds that are incompatible with each other. But these AR clouds constitute essentially point maps of the world that are maybe created from photo data or created by other sensor measurements. So somebody, a developer or a user, takes pictures in the target environment. These are uploaded to a mapping service and stored in the AR cloud. And next time, the user can basically, the user device can recognize the same place again. and anchor a digital asset to this location that is represented by this point cloud map. If another user is coming or another location, the two users can localize in the same map, get into a shared universal coordinate system, and they can retrieve the virtual object, which is this fountain in this case. And it appears at the same place, at the same location for both of them. And this is why you need very accurate localization to make the digital contents appear at the exact same position for everyone and at every time. People call this spatial anchors, which is essentially these kind of maps and persistence of the objects together with the maps and discovering the objects that are around you. Yes, so today, if you need this kind of accuracy, you need, let's say, 5 centimeter or 1 degree error below these values, and that means that today already the vision-based localization can support these kind of accuracy. So the GPS is not as accurate. So typically, these systems work the following way. This is a picture from a publication from more than 10 years ago, but essentially it very nicely depicts the general architecture. So there is a mobile device on the left side, which is running some local relative motion estimation in some local coordinate system. This can be a visual or visual inertial odometry. It has a high update frequency and low latency, so it's very fast, but it is drifting over time. It has limited resources, and it has no notion of the global coordinate frame. On the right side, on the other hand, we can have a visual positioning service, which includes a map or maps of the world that are optimized over long time. They are built in the cloud. They have, let's say, no drift and unlimited processing resources, but they are relatively slow to use for localization. And combining the two is done in the following way. So the mobile device periodically sends certain keyframes or some other localization data to this localization server, and then the server tries to align the map, the image with the map, and then returns the transformation that brings the image into the global coordinate frame. And if this is known to the mobile device, then the mobile device can reorient its local coordinate frame to be matching the global one. I mentioned that on the right side, this is usually a point cloud, but it can be some other method. You can even these days train a neural network to do localization. So there are plenty of methods, but the general architecture is like this. And on the left side, we have many different VIO engines. ARCore and ARKit, they are the ones built into the mobile operating systems. There are also other ones. A Finnish company called Spectacular AI, for example, that is offered for robots, but there are plenty of others. And on the right side, Google, Apple, Meta, Niantic, Microsoft, they all offer visual positioning systems, but unfortunately they are proprietary and not compatible with each other. Also some startups, for example, Augmented and Immersal. But again, these are not compatible with each other. It would be so nice to have a standardized protocol here in the middle, so that any mobile device can talk to any of the visual localization services, because all these are somehow limited to locations that were mapped by the respective companies. And it's hard if you're a developer or an end user, if you want to map your own space, you are basically stuck. Because just an example, Google cannot enter your apartment for mapping, so you have to do it yourself somehow. So our idea was in the open air cloud for a long time, and also in this MSF forum, to create something that is open and can be modified by anyone and can be hosted by anyone. Luckily, this year we won some funding for this, and we developed this inside Nokia and release it in the OpenAI Cloud GitHub repos. The overall architecture is relatively simple. So we have 3 components. There is a map builder component, which takes in images from some recorder app, and it builds this feature point cloud map that I showed before. But still, it has some arbitrary coordinate system, so one more step is necessary. And through a map aligner tool, we load this point cloud map and an OpenStreetMap traditional 2D map tile, the building footprints, and then one can align the point cloud with the world. This results in a geo-alignment transform, and the feature map together with the geo-alignment transform can be put into a map localizer component, which is again a web service, and an AR app can send images to this map localizer and get back the GeoPose of that image. Okay, here again, example photos in front of my office. This is how a map looks like typically, and this is how the geo alignment looks like in the map aligner. And I will go now more in detail in each of these components. So the first step is to capture photos, but it's good if you not only capture photos, but some additional data. For example, the relative motions between the photos, or also depth information can be useful. And originally we wanted to create an app for this purpose. By the way, in a previous OpenAI Cloud project, we already created an app for Android, which collects similar things. But now here we have one for iOS. I found this, and it records actually almost everything that we need. It doesn't record GPS, which would be nice, but maybe somebody can extend it in the future. So as an end user, you only have to walk around and capture a video, and this app captures everything else in the background. You can zip it on your phone and you can upload it to the map builder component. The map builder component looks like this. It's a very simple user interface. And there's a big upload button, and then you can upload a data set. Each line is a data set. The data is automatically extracted, formatted, resized, rotated, a thumbnail is created, and then it starts the mapping pipeline. What else we see here is there's a login here, and the buttons. I will show these, explain these later. But you can start the processing. You can download the resulting point cloud in the PLY format. You can start the map aligner with these arrows. You can start serving it in the localizer with this pin, or you can rename or delete the map. So fairly simple. And I'm not super happy with this GUI, but yeah, this is enough for a prototype. And the core of the localization is not our work. We just took some existing localization framework from that is very popular in the research literature. It's called hierarchical localization. It was also mentioned several times in this work group. It is hierarchical because it operates in 2 steps, both in the mapping and the localization phases. First, the mapping images are taken, and each of the mapping images is sent through some global descriptor extractor component. So essentially, every image is represented as a long vector, very long vector, and these are put into this global index. Then similar images or neighboring images are found based on these global index, and then between those neighboring images, also local features are extracted. So these are basically the corner points of the images, and these are put into a structure for motion reconstruction pipeline, and the end is a structure for motion model. And in the query phase, the query image is also sent through the global descriptor extractor. So we get one long vector that describes the query image. There is a nearest neighbor search in the global index. So we find essentially the the closest n is typically like 20 images from the database, so we know roughly where we are, and then we do only after that, with these 20 images, we do the very costly picture matching. And if we find correspondences between the 2D corners of the query image and the 3D corners that are found in this SFM model, then we can estimate where is the image in the point cloud. The point cloud looks like this for the square in front of our office. So again, this is hierarchical localization framework is from ETH Zurich. The GitHub is here. We picked this one because it's very easily extensible. So basically every month there are some new feature types appearing, and there are lots of research papers in this domain. So we wanted to stay future-proof by taking a framework that can incorporate many different types of features, both global features and local features. There was one issue that originally the framework was built for offline benchmarking, when you have access to all the mapping images and all the query images at the beginning. But this is not the case for us, because we want to have live localization of live queries. So a lot of refactoring was needed to make it work with live localization queries. So once we have the point cloud, we load it into this map aligner tool. It's again fairly simple. It has a map view and overlaid this point cloud that is created, and then there is this gizmo tool for rotating and translating the point cloud. And there's also some sliders, and scale adjustment is also necessary at this moment. This is one current drawback, and I will have a slide about possible extensions. This would be probably the first thing that should be added. But at the end, when you are happy with the alignment between the point cloud and the building footprints, then you can export. There's a big green save button. You can export this transform, and this is written back to the map builder next to the map itself. And there is a map localizer component, which talks OpenAI's GeoPose protocol. I will talk about this on the next slide, but this is essentially is meant to be between the mobile client and the VPS service. So it can, and there's also some demo client created so that you can test with different images. And it sends back a GeoPose response. Also, in this localizer, a feature map can be loaded dynamically based on its UUID, but the current limitation is that only one map can be loaded at a time. So this active map can be configured in the map builder, but in the future, it would be useful to extend the whole system with something like a map selector that, based on some previous knowledge, for example, a GPS measurement or some other course estimate, submitted together with the query, and then it would select the right maps to do the fine localization. Yes, and then once we have the localization via HLoc in the point cloud, we apply the GeoPose transform and express the final pose in GeoPose. This is how the protocol looks like. Maybe many of you have seen this in this.
And I'll just pause here to say that when we look later at the GeoPose components that we're working on in the OGC GeoPose SWIG, that in effect we're trying to define components that are pieces of this pre-existing protocol, not completely, but as much as possible.
In this group, but a request essentially has camera readings. This is one image, but it could be actually more. For example, smart glasses, they have many cameras. You could use many of them for localization, and a geolocation reading, which is which contains the GPS measurements of the phone. So these two are enough for localizing something more complex. And the response essentially contains the geoposition and the orientation in the east, north, and up coordinate frame. And there are some IDs and timestamps that are matching between the two.
So that was an overview of the work that really stemmed from the OpenAR cloud and their the OSCP GeoPose protocol, which is the request and response sequence to actualize the request and to the visual positioning system and the responses. So that's the topic specifically that we're addressing in the GeoPose standards working group. For comparison, we started a project at the beginning of the year to also within the real virtual integration working group or domain group to make in some ways a tiny modification to what Gabor talked about, and Gabor actually described at several points in his presentation that excuse me, that the what I would call the memory of the visual positioning system. So if you are feeding it images that you're using to build the local map, that thing that you've built is the local memory. So in the HLOC system, the ETH Zurich project, that's a point cloud, and matching of images to that point cloud happen by finding features within the new image that match features in the point cloud, and that's how it works. The difference in the radius field modeling GPS prototype is that the memory is a radius field modeled as a field of 3D Gaussians. So that's directly aimed at this visual positioning system use case, but involves some things that are really more image related than GeoPose related. So I personally felt some tension between the introduction of some of these parts, mostly drawn from the OSCP GeoPose protocol, to describe the requests and responses to a visual positioning system, because they're not core GeoPose. So that's definitely a topic for conversation. There's a link in the slides which has a lot of detail about the radius field model prototype, but it's based on this ability to do a comparison, a benchmarking between the data capture where we had actual car driving and people walking and doing the rendezvous, and with instruments that were measuring the location orientation of the various imaging sensors. So we had the opportunity to estimate the performance. You remember back in Gabor's presentation, he said less than 5 centimeters and less than 1 degree. So it's a question of how reliably can these different approaches to visual positioning meet these requirements. And that's really the topic of this prototype development. So it's very similar to what Gabor described. It simply uses a different mechanism for remembering what the pre-scanned or in sequence scanned views of the environment are. And Gabor talked about sort of two separate phases, one pre-scanning the environment and then using it for visual positioning. We're also looking at what happens if you try to do a cold start of a visual positioning system. So you start out with no information, and you get one image, and then you get two images, and you get three images. How do you how does the behavior change over time as you add more information? That's one of the new questions that we're trying to answer with this prototype. And finally, I think Christine is going
Yes,
to,
I'm going
let's
to
see.
answer. Actually, if you go back to the slides themselves, I embedded these slides into the presentation. Right?
Okay.
Okay.
So
Yeah,
what
so
we're looking,
yeah,
we're
go
looking
ahead.
at, well, we're looking at the program, the Forum Labs within Metaverse Standards Forum.
Right.
Go ahead.
Yeah, thanks, Steve. So what we've done over the last hour or so is to set up this parallel between the visual positioning that can be done on a point cloud versus being done in a radiance field file. And so what we have is two, and there could be many more different approaches to describing the world. And we heard from Simon about the project that was done for the area that had to do with benchmarking. Now, the method that Simon and Tony used is a proprietary method proposed for area members to use. It's funded, the project was funded by area members and is, at least for the time being, their property. However, there are many ways to benchmark services and to better understand the dynamics. And what we're going to talk about for a couple minutes here is a project that started about a year and 3 months ago in the Metaverse Standards Forum to have laboratory research infrastructure that is provided in partnership with the forum by organizations that are themselves labs. And so this partnership is a win-win program so that the forum gets to test things in the real world, refine our requirements, explore perhaps new requirements, and apply the things that we're learning and the things that we're studying in these controlled environments. The labs themselves on the right-hand side will get more visibility. So perhaps people don't know about these labs. People will have more uses and more attraction to these labs after they learn about their capabilities. And so the forum is also adding to the lab's credibility, and we're going to collaborate on interoperability projects. So this proposal that you see here on the screen has gone through several iterations and has been discussed at the board level. And we're just kicking that off. In fact, thank you to Steve and to Gabor and those of us who are involved in these projects. We are in the process of piloting the whole Forum Lab system using the visual positioning system benchmark. So go to the next slide, please. So, working group members, including those from the Real Virtual World Integration, are describing a project and I'll get to that in just a minute. That project description is going to evolve over time. It's going to have a set of KPIs and deliverables that then the project will be reviewed until it's ready and it's approved, and then people will go off and do the work, come back and give us insights that we otherwise would not get. And many of those insights will get published and be public deliverables shared with everybody that is interested. Go to the next slide, please. So, so this is the idea of the Forum Labs. As I said, it hasn't been proven, but we are all eager to pilot and to test this concept concretely. And so I created a template saying, well, if you're describing a project, what do you need to know about it? And proposed some fields and so forth. If you go to the next slide. And then, yeah, so Steve has taken the information that he's compiled and has been developing over these last couple of years and over the last 6 months, conceptualizing this competition or comparison between two VPS approaches, and we can learn so much by tweaking the dials in various ways to measure what has the greatest impact on performance. So in contrast with what Simon was talking about, which has a lot of technical underpinnings, but it's also very, very driven by business needs, business requirements, and those that were defined in the enterprise AR use cases. In this case, we of course want to be able to meet those business requirements, but our first order of business is really to study the science, how these different sensor systems, how the capture systems work, how do they work in the context of a 5G network, what happens when you manipulate these, and using the Hillyfield's data bubble as ground truth to anchor all of this. So there's really an exciting project to, again, perform these measurements and just to develop the benchmarking techniques that then others can use as they're creating visual positioning systems in the future. So we've got the first deliverable is a methodology. Of course, we're going to publicize that in a variety of different ways, share the results that we got using the methodology, and then, of course, publicize the whole package and rinse and repeat. So in this slide, I can I'll share the link to this document that that Steve has been developing that describes this benchmark for the Forum Labs. And we do have the lab partner. It's an organization in Greece that is a center of excellence in 5G networks and is very excited to work with us in this pilot phase. That's what I have to say to introduce the Forum Labs initiative and to explain the connections between what we've heard for the first part of this workshop and set the stage going forward. I did want to say something else too. I wanted to express caution at a couple of levels. One is that in one of Gabor's slides, he has a picture where he has, the AR SDKs and kits on one side and VPS is on the other, and he has this picture asking if there's not a standard VPS, if there's not a VPS standard. And I want to express a lot of caution around that. I don't think there is a VPS standard. I think the VPSs are composed of many, many moving parts, and we can have greater innovation if the moving parts can talk to each other and integrate in a variety of new creative ways. I don't want to give the impression that there's going to be one VPS, and I don't think that is what Gabor is talking about, but in my opinion, and we can get into this during the discussion section, this workshop, I think there's lots of parts that can be decomposed and studied. And I don't think the OGC GeoPose is the place for all of those, but let's keep going and uncover the different elements. Steve, back to you.
Okay, well, that was a good point. But the parts maybe are the things that are shareable, and that's actually the approach that we're taking in the GeoPose standards working group, is to look at the parts rather than defining overall architectures or interfaces. So that's our strategy, and hopefully we'll be happy. So the three areas that we're looking at that have to do with supporting visual positioning are time and uncertainty, which you might call quality or measures of quality. So time, uncertainty, or quality, and then image specific things. And again, that's in the category which they definitely are required in order to do visual positioning, but they also pretty definitely don't look like core GeoPose. So it's an interesting juxtaposition of supporting a use case and sort of a pure technical theme. So we'll start with looking at the time coordinate. And again, it's called time coordinate because we think that we just need an axis which we can position ourselves in time from time to time. Rob?
Okay, so would you like me to explain this in terms of what we're thinking, or do you want me to start with the use cases? As everybody seems to have been talking about use cases so far.
As you wish, just tell me which slide you want to start on.
Okay, right. So let's go to the second slide then. That's not the way I was going to present it, but to fit with what's been said so far, it probably makes sense this way around. So a lot of people so far have been talking about GeoPose in terms of an image. So just to give a little background about myself, my name's Rob Smyth from Away Team Software. I'm an invited expert in the spatial temporal data on the web group. It's changed its name recently, which is a joint committee between OGC and W3C. So I have a foot in both camps. At OGC, I'm involved with GeoPose, obviously, and also moving features. And at W3C, I'm leading the development of Web Video Map Tracks, WebVMT, which is for synchronizing location with video for the web. And hopefully you're starting to see why I'm interested in timed GeoPose. I've recently done some work in the testbed 20 at OGC, and one of the use cases I looked at there was an aerial observation use case where an aircraft was observing a truck, which you can see in the left-hand image here, which is moving along a highway in the US, and the aircraft is circling, so this view rotates around. And what we did was to export the MISB metadata which is timed video metadata from the video, and specifically the frame center and sensor location tags.
Web Video Map Tracks, or WebVMT.
Oh, and here I am presenting it.
Location with video for the web. In testbed 20, Away Team analysed 2 geotagged video use cases to improve data quality and image cognition. WebVMT footage was recorded with the TrackCam smartphone app aboard a sailing boat, shown in orange, and aggregated with AIS data that tracks maritime vessels, shown in blue. A navigational issue was identified from OpenSeaMap data and corrected by adding a single interpolated waypoint. This significantly improved the AIS tracking accuracy to within 10 meters of the vessel's course. Aerial surveillance video of a truck driving along a Wyoming highway was filmed from a circling aircraft. In-band MISB location metadata for the sensor location and frame center tags were exported to two WebVMT paths, shown in orange and blue respectively. A WebVMT utility was developed to calculate the GeoPose of one path from another. Interpolating these values allows smooth rotation of the map under WebVMT control. Matching the map's rotation with the camera's heading simplifies geospatial cognition of the video footage. When combined with photogrammetry data, this feature enables the location of any objects visible in the video to be identified quickly and easily, including those that don't appear on maps. WebVMT simplifies geotagged video analysis in a web browser. Sensor and map data have been successfully aggregated with video to significantly improve tracking accuracy. Video cognition has been enhanced to facilitate accurate location of any object visible. Full details can be found in the Testbed 20 engineering report.
Thanks, Steve. That saved me saying all of that. So now you can see what it does. If you want to have a look at that again at your leisure, I've put a link into the chat which is on the WebVMT site, which has that video and a few others as well. Some demos of what can be done. But specifically for that one, we're using the GeoPose to align the map, the web map, with the video camera's heading. So it simplifies cognition. You're getting the same perspective in the map that you are in the video. And when you combine that with photogrammetry data, you can see anything you can see in the video, you can also see on the map, which includes things which don't appear normally on maps, like the street light, which you can actually see in the image that's on the slide there. If your eyes are good enough, it's just to the left of center of the image, top and bottom. You can see its shadow easily on the bottom image. So that's a use for time GeoPose. And if you want to try that for yourself, there is an app that was developed in Testbed 18, the 3D Campus, which you see on the right-hand image there, which is free. So you can download that onto your Android device. And I will paste that link that you see on the screen into the chat as well, which means I'm just about to lose the entire audience, who will then be fiddling with their phones. But no matter. There it is. So these are the drivers. So if we go back to the design, the previous slide, please, Steve. We've already integrated GeoPose with WebVMT in the Hillyfield's bubble dataset, which Steve mentioned previously, in a static way, because it describes the location and orientation of the roadside cameras that we used for the filming there. But that is the old version of GeoPose. That's GeoPose 1.0, and it didn't really use timestamps. What we're trying to do is to introduce a standardized timestamp here, and we would like it to have nice characteristics, which I'm being deliberately vague about, but they are described here on this slide. So what we would like is a monotonically increasing number, which is easy to deal with. In answer to John Eric's question, they can be any unit you wish. It could be milliseconds, seconds, days, or whatever. I'll come back to that in a sec. But what we want to avoid is any sort of complex notation like hours, minutes, and seconds, days, months, and years, and discontinuities like leap seconds, which occasionally get added at the end of a year. So far, we've only had positive leap seconds. They've gone forwards. But there's a possibility that we could have a negative leap second, and that leads to ambiguity because now you've got two times which are apparently the same, but 1 second apart. And that's going to cause a lot of complications. So what we're proposing here is that there's a monotonically increasing just a number of ticks. So that makes it easy to calculate the numerical duration and time difference just from those numbers of ticks. And then we can reference that against whatever time reference we wish, temporal reference, by having a point, an epoch, which could be the start or some other point or possibly many points if there's some reason for discontinuity within that timeline. And that can be related to things like Unix time, universal time, international atomic time. I was trying to think of some other examples. Modified Julian day is used quite a lot in space applications, which uses units of days. And really whatever temporal reference we want. And this follows the GeoPose design of being a container for whatever the use case requires. So people can adapt it for their own personal use. And the diagram here is just a simple representation of that. So we have a sequence of geoposes, 1, 2, 3, 4, 5. Each has a geopose, and there's some progression of time through that. So very, very simple. But that can be adapted for whatever the use case is. Do you have anything to add to that, Steve?
Well, thank you, Rob. I guess the one thing that you did highlight was that the OGC's testbed program has been actually key in prototyping and developing some of these ideas over actually the last 5 or 6 years in your case. So that's very similar to well, it's not completely parallel to the Forum Labs idea because it doesn't involve different outside organizations, but the prototyping workspace that OGC provides has been really valuable in actually testing ideas and learning by doing. So I feel like a lot of what you've done has come from that.
Yes, I agree. The best way to learn about things is to do them. It's all very well talking, but you often miss the details and very important details. And it only comes when you come to do it physically that you go, oh, hang on, there's a vital piece that's missing here. And I hadn't appreciated how significant that really is. But we have working solutions and demos, which is always helpful. But I agree that the Forum Lab sounds like a great idea to get a wider audience and more participation.
Well, thanks again. So time, just a point in time, a way to describe where you are in time. We did naively have the ability in the advanced GeoPose to add timestamps, and we chose Unix time as a definition of how far it was between the ticks, and that actually, in retrospect, wasn't a very good choice because there's leap seconds, and there's different treatment of the leap seconds. And so some libraries stretch the time 1 second over 2 seconds. Some just have a discontinuity. It's not good. So we definitely need to do a more precise targeting of what we really want, and that's the point of time. So uncertainty, and Jim Anthony's couldn't be here today, but we've had an ongoing discussion, I would say, with two different points of view on uncertainty or quality. And I think the value of quantifying uncertainty is that you're defining quality. So I feel a little bad about always calling it uncertainty because that's kind of a negative thing, and quality a good thing. But that's what we've called it. And the two approaches I've called value uncertainty or objective uncertainty. So with value uncertainty, we have sprinkled throughout GeoPose 1.0 and certainly in later versions, we have numbers. And if we have a number, then we should be able to define measures of how good those numbers are. How repeatable are they? What's the precision? How close are they to the true value, accuracy? And how precisely can we represent values or granularity? Excuse me. Or if it's a category, so you're saying this is a tree, or this is a person, or this is a hedgehog. What is the confidence in that assignment? So these are all places where it's pretty clear that you can define something that applies to numbers or categories. And even as you develop new components, new pieces of GeoPose bits that you can combine to make useful things, like a whole GeoPose, that you can apply this value uncertainties to these things without knowing in advance what they are. So that's good in the sense of sort of future proofing, but it's not good in the sense of, well, what if I really want to know how close is this position to where I say it is? And Jim has taken a point of view that, for example, we might use a positional uncertainty ellipsoid. So we might have a three-axis ellipsoid of uncertainty, where the surface of the ellipsoid defines a bound within which there's a 95% chance that the true value is actually inside. And this, so GeoPose, sort of superficially is a position and an orientation. So what's the equivalent to an uncertainty ellipsoid for orientation? It seems like angles are a reasonable approach to that, or could be direction cosines or something that in effect maps to an area on the surface of a sphere that gives the pointing precision, accuracy, or granularity in terms of orientation. So I think we may be headed toward both the value uncertainty and the objective uncertainty approaches in defining uncertainty. And we'll see that more when we actually look at the components and some proposed ways of modeling little bits or the bigger bits. So the final area are these image elements. And I've previously called this visual positioning support, but this is really the part that really focuses on images. So I've started calling it images. And if you think back to Gabor's presentation, and I stopped it at a certain point when there were bits of the GeoPose protocol visible on the screen, that what we're trying to do is identify pieces that are either already defined within GeoPose. So in GeoPose 1.0, a lot of things that I'm calling components now were called structural data units, and they were pieces from which we built up actual geoposes. So something like a position, or yaw, pitch, and roll angles, or quaternions. Those are the things that I'm calling components now. And if you look at the OSCP GeoPose protocol, then you see, which comes in OpenAI Cloud, you see these pieces in there. So our goal, which can't be met totally, is to take those pieces that appear and turn them into image support components if they relate to the images. So now we'll actually get into the details and start what I hope will be interactive in terms of discussion of whether a particular component is in scope for GeoPose, whether it's described in a useful way, whether there are requirements for pieces. So there may be properties in a data object, and so most of these are described. So I've built a tool chain, which isn't really totally perfect yet, starting with C++, class definitions, which turn into JSON schema equivalents, which are actually okay at this point. But the translation to UML has some quirks, and so you'll have to be patient with those. But the point is that for each of these classes, and these are just proposals, except for the core, which are left over from GeoPose 1.0, the question in that we need to consider and possibly answer is whether they're in scope for GeoPose, or whether they're part of a package of support for a particular use case, in this case, visual positioning. I've made some requirements for defining a component. It needs to have a use case. So the use case for all these that we're talking about today is visual positioning. It must be conceptually in scope. And I've cast some doubt on any of the image related ones being actually in scope for GeoPose, but they're certainly useful for the use case. So they're useful, but maybe a sidebar to the core development of GeoPose 1.x. Needs a machine readable schema. I've gotten tired of using Enterprise Architect and drawing UML diagrams. Partly because there's no standard serialization format for the UML. So you can create XML files, but they're like super awfully bulky, and you can parse them and you can turn them into something more palatable, but it's not pleasant at all. So I've turned my thinking inside out. And again, as I said, I start with code, in this case, C++, and generate JSON schema from that. And the idea is of using JSON schema as the schema definition as opposed to definition of a schema to be realized in JSON. So how do you do that when you have a limited number of data types in JSON? Well, I'm using the format property, which lets you suggest how you might implement something like a number, because a number might need to be a 128-bit integer in order to do the job that you need it to do, or it might be a byte, and being able to say what you really want that to be, if more detailed than you can do with JSON in a JSON document, is important. So I think JSON schema is able to do that. I mean, you can do that, and I think it's acceptable to the universe to do that. But feedback on that point is something that will be valuable, and maybe we'll get some today. Yeah, that's really, so we have 25 of these components.
Can I interject
Sure.
just a second? So one of the things that I forgot to turn on my video. One of the things that I thought of when I heard you talk about the image components and so forth, the challenge for me is always, if we're not going to define it, and I think we don't have the in-house DNA to define it, which standards development groups should be enlisted or convinced? So it's not something to answer now, but I just want to come back to when we get to the periphery of our wheelhouse, it would be really good to have some targets, which working groups in which SDOs have the capabilities. So several months ago, Gabor and you, Steve, and a couple of others, we wrote to the Camaros working group. It's a Kronos group working group, and they're working on camera APIs. And we gave them some requirements, which they haven't gotten back to us to say if they would or would not be in scope for the API. But I just wanted to use that as an example that we do have to be thinking about where else, if not in our group.
So I think actually it's important to create at least a straw person way of structuring these data objects, even if they're out of scope for GeoPose, because I think visual positioning is such a core use case. I mean, at the high level, visual positioning is you give something an image and it gives you a GeoPose back. Or in some cases, you may be able to give it a GeoPose and get an image back. This makes it important to GeoPose, even though the bits and pieces maybe aren't really of the GeoPose species. So it's maybe symbiosis is a good analogy. But I think if we go ahead and define them, and then we maybe use them as an example or as a recommendation or something like that, that we've got a proposal that then we can go to these other groups and say, this is what we're doing. does it conflict with the way you're thinking or the way you're doing things? How should we change, or should you change? And we can start the conversation. But I think it's one of those chicken and egg things where if you're just talking but nothing actually is out there to concretely pin your discussion to, then it's much less valuable and much less likely to result in anything useful. So of course, I'm always in favor of just plunging ahead and doing things. And that's maybe what I have to say about that. So thanks, Christine. So I'm going to start off with the core components, and these, with the exception of the coordinates at the bottom, are part of GeoPose 1.0. So there has been, I won't call it confusion, but sort of semantic double vision sometimes with regard to the names of these components. For example, position. So if you look at OGC to understand what a position might be, you'd say, well, just think, well, that's where something is in space. But there's a lot of nuance and there's a lot of different points of view on what it is really the concept and how you represent it, and what other baggage it carries with it. So it would be better in some ways to call this X375 or something like that instead of position. So this position component is specifically a geodetic latitude, a longitude, and a height above some ellipsoid. It's a geodetic position. It's what you would get from a GPS, or it's what you would hope you would get from a GPS. Not always true. So it's position, but the position name, the problem is that the position name is semantically more inclusive than what's actually being defined here. So it's not something I want to fix. And for backwards compatibility, we probably wouldn't want to fix it anyway, but I'm just pointing out that it's named position, but it's a specific kind of position, and it's represented by these three numbers. And these three numbers have a connection to other stuff that is used to interpret what those three numbers are. Quaternion, on the other hand, doesn't have that problem. It's just a mathematical structure, and it's if you're familiar with it, something that's better behaved than angles when it comes to interpolation in particular. Angles are angles, but again, like position, the angles here are specific angles. They're yaw, pitch, and roll. They're not just any angular measurements, three angles, for example. So I'm explaining this to give context, not really soliciting any fixes or suggestions in most importantly because we need to maintain backwards compatibility. But giving these data objects these possibly two generic names for simplicity's sake has some consequences, and the consequence is that you may misinterpret something called position as like, well, just a point in space. Now, on the other hand, the fourth thing here, coordinates, actually can be that generic point in space. It's some coordinates, and it's not even a specific number of coordinates. It presumes that if you look at the coordinates, you can see how many coordinates you have. So if you have 3 coordinates, it's like a 3 vector, for example. If you have 2 or 4, it's 2 or 4 space. And in OGC testbed 19, it turned out that this was needed in order to model a lot of things, local coordinate systems. We use the name local in testbed 19, but I think coordinates is a better choice. So look in detail. And I invite anyone to simply speak up if there's something that you want to contribute as we go through these. So position I talked about, quaternion, it's really unit quaternion, so that the norm of the x, y, z, and w values is 1. Angles, yaw, pitch, and roll in degrees. And coordinates are just an array of numbers. And the number of numbers is presumably explicit or implicit in the representation. So in JSON, for example, it would simply be counting up how many you have. In some other representation, maybe a binary representation, you'd need to prefix the values with the number of values. So that's it for the core components, mostly derived from GeoPose 1.0 or work in testbed 19. So Rob talked about time and a position along a time axis where the time axis has values that correspond to a count of ticks of something, and there are no changes in scale or discontinuities in the axis. In other words, it's a normal one-dimensional coordinate axis. And sometimes we just need a number. So if you have geoposes or visual positioning parameters, anything that you need a time axis, that time coordinate value, then if you are defining the time starting point within your framework of whatever you're doing, so you know what the time start is and you know what the time unit is, then you know everything already. And so you just need the number. But then sometimes you might want to relate that to some other time system, like UTC or Unix time or International Atomic Time corrected to the geoid or whatever you might want. So the single number, which is a point on a time coordinate axis, is called an instant here. And an instant here has the possibility to have well, there's instant and then there's instant 2. So instant has all of this built into the structure. Instant 2, which looks better to me, has an optional time origin built into it, where a time origin is a combination of an epoch. You might think of it as just a time offset to the origin of your local coordinate system and some kind of identifier for time coordinate reference system. Now within OGC, there's been a lot of work on defining coordinate reference systems and ways to express definitions of coordinate reference systems, both for spatial and temporal coordinate reference systems. But I've had a lot of trouble actually using them. So, and I've been encouraging those groups to meet our needs better, but things take time. So I don't have a good answer, and I didn't have a good answer in GeoPose 1.0 either for how to define coordinate reference systems in a way that's useful, because there are many incomplete approaches to that, supported by different libraries and different standards, and it's not easy to decide on just one, and maybe not wise to decide on just one. So,
Hey, Steve, should we pause there and ask any discussion? Does anybody, Rob said you could relate to, since just Generic's got some thoughts. What maybe input?
yes, please.
I just
Generic.
yeah, somebody rang the doorbell, so I might have missed a little bit of the explanation around this. This seems like time coordinate reference system or something. Is that the definition? So you could like put in any known system that has kind of epoch numbers. Is that the
Well,
just
okay,
like this?
So what I was really complaining about was the fact that there's no easy way to reference this information in a standard way. If you want to relate your local time coordinate to some standard time coordinate reference system, you typically want to specify an offset. So your starting point, where your origin is in time, your 0, in that other system. And you also want to identify that other system. And the identify that other system part is the part that doesn't seem to be very well supported. So I don't have a solution to that. Maybe someone does have a solution to that, but simply saying, well, let's just call it a string, and maybe if you can understand what that contents of the string are and define the actual temporal coordinate reference system, then it works. So, yeah, I know.
Yeah, like we could kind of just pattern on what you do often. Like you would use this EPSG colon and then some number for geospatial coordinate reference systems. So that's like an established pattern. So is that something like you put a string there? Is that kind of something you could imagine having there, that there's this kind of agreed upon repository where you can find all these time coordinate systems, and then you could
Yeah, I've thought about that. I haven't really talked about that much, but one of the things I thought about is building a table where we have EPSG codes, and we have proj names, we have other things that are like that identified as being this in a table that are the same or not the same. And then we have a column in that table which has our GeoPose code number, let's say, that's equivalent. So you might have EPSG 40 through 26, so 3D WGS 84, latitude, longitude, and height. We might call that, GeoPose 003 or something like that. And I see that not as an end in itself, but I see that as a useful contribution if we can identify in our standard or in a best practice an identifier. So following the EPSG approach seems like the most regularized one out there. That if we could follow that, that maybe some other organization more specifically focused on those issues would then take over or adapt or define a transformation or conversion between their scheme and that scheme. At least get the conversation going, because right now it's just not very, you have to do a lot of research and learn a lot of things in order to even understand what you want to do. And for a developer, that's really not very handy. You just want to be able to use something. So if we do the work of interpreting for some common temporal coordinate reference systems, let's say, and identify them with our own identifiers, that maybe we actually become useful to developers who want to use those temporal coordinate reference systems, but don't want to do the research in order to understand what they're doing, or just pick, or make a mistake by just picking something without realizing what the consequences are. So that's kind of a not really a rant, but it's kind of a rambling description of, I think we have to do something on our own, and we shouldn't actually have to do that long term. So Rob, did you have any?
Yeah, so I've just had a quick look at EPSG, and I see that there are a couple of numbers already allocated there. So they've already thought about time, but only in terms of time units. So seconds and years both have EPSG numbers associated with them, but there's no temporal reference system, so no universal coordinated time or international atomic time, which are the sort of things that we want, I think.
Yeah, I mean, that's what's out there in the landscape. It's like partial solutions or things that work well for one or two coordinate reference systems, but then may even have mistakes in them for other ones. It's discouraging, but that's why I think if we pick like a small number of useful ones and we just write them down, then if we made a mistake, people will point that out, I think. But if it's right, then it's useful, and it eventually will get read by a crawler and incorporated into large language models, and then everybody will be able to use it.
Yes, I think that's right. And taking a lead on it is a good idea, or making a suggestion is a good idea, rather than saying we don't know. The other suggestion that I have to make is I believe that W3C generally uses ISO 8601 format. I was just looking that up to work out what it actually relates to.
It's more representation than it is,
Yeah,
visual representation than it is.
Which reference system is behind it?
Yeah. So we should. So my opinion is that we should do a few useful ones, where few might be like 3 or something like that, and then hope for the best. But just casting people adrift actually didn't work well for the advanced GeoPose. So that's what I'm thinking.
It did not work well for that. No, it was poorly received.
So I notice in ISO 8601, you can put UTC, which is definitely a temporal reference system, explicitly. So, I mean, that strikes me as a way as a good basis, because you could replace UTC with the temporal reference system of your choice. TAI or whatever it is.
Yeah.
And that's a well-known, well-defined, well-used starting point.
Yeah, no, that's a good suggestion.
And if we upset somebody, they'll come and talk to us fairly quickly, which might help to resolve it.
That's true. That's the value of using something that's sort of the number one choice, is that if you fool around with it, they'll come after you.
There's a link in the chat if people want to have a look at that.
Thanks.
What about going to the working group that's responsible for that? I mean, is that possible?
Yeah. Chris Little's the man to talk to. I can certainly reach
Chris
out to
Little.
them.
Yeah, Chris Little, yeah. Okay, thanks.
Oh, I guess to summarize, I'm thinking this instant so to summarize everything about time that I've thought about is that instant 2 is better than instant, and duration. Rob's didn't like duration because he thought it was like could be made up of instants, and I'm not sure if he liked instant either, but as a name. But I like instant as a name, and it seems fairly standard. So anyway, so I would suggest it seems to me that there's favor for instant 2, which needs a time origin, and getting this identifier defined maybe requires us to do some extra work.
Yes, my comment on duration is it feels like we're trying to reinvent the universe again. It feels as though we're extending the scope of GeoPose into time and trying to solve all those problems, which are quite honestly somebody else's problem.
Yeah, no, I agree. You convinced me. So, are there any other time comments? If not, then we'll go to quality or uncertainty. I'm starting to feel really bad about uncertainty being negative and quality being positive, but I've been calling it uncertainty for a while now. And we had this between the idea that if we have numbers, we can assign them precision, accuracy, and resolution values also as numbers. And if in the future we have more things with numbers, then we can always assign this kind of qualification to them if we have a value to apply. And that's the argument for targeting numeric values and confidences as kind of a derivative of that.
Hey,
And then,
Steve,
yeah.
two comments. One is Jean-Eric put some things into the chat that was back about the time, sort of related to time, but pertains to this too. And the second thing is that I think it would be helpful for the uncertainty discussion to do like Rob did for time, which is to really make sure that the requirements are well understood. And with the requirements, we knew that uncertainty was going to come up 5 years ago, 6, whenever it was, that it was a consideration, but in the I guess 6 months ago or so, the use case and the request really crystallized. And this reminds me a little bit of the situation with the VPS standards. It's like, is this something that that has to be written into a standard, or can we not use an existing standard? I mean, you're a big fan of doing that. You know, create, just like we were talking about a few minutes ago with time, there's prior art, there's good work that's been done in this area, and can't we normatively reference some of that?
Oh, that's a good suggestion, and that's really part of Jim Antonisa's thread, which looks at end use driven requirements for what the quality characterization is, or the uncertainty characterization is. Whereas treating any number as something that you can quantify the uncertainty if you want to. So I would argue that in the case of numbers, that you can simply refer back to statistics as the definition of what all these things are and the interpretation. So in many ways, it's not even it's simpler concepts that don't require much explanation, I guess is what I would say. But in the context of visual positioning, which is where we are today, that one requirement that Gabor gave of less than 5 centimeters positional accuracy and less than 1 degree orientation accuracy, that's the one stated requirement that we have at this point. So in many ways, if we're looking just in that context, which is the point of today, then Jim's idea really comes from NGA work that he's done or is familiar with, that using an uncertainty ellipsoid is directly useful in terms of knowing, well, is there a surface within which I can have a certain level of confidence, let's say 95%, that the true location of the point is within. And that argument makes a lot of sense, but it's very specific to position. And I tried to think of what's the equivalent for orientation. I would have hoped that Jim could answer that, and maybe he has another answer. But if you look at an arrow or a vector pointing in a certain direction, what's the range of directions it could point that would be within, again, some like 95% confidence surface or surface patch on the sphere. This drawing doesn't do a good job because you don't see the sphere, and I hoped that I could tuck it into making a sphere with the circle on the sphere, but it's just kind of pointing at the North Pole and no sphere. But the idea is that that red arrow can be pointed in any direction within the blue circle, and that blue circle is the measure of orientation and uncertainty. So that really, from the point of view of Gabor's requirements, certainly answers those two questions. So that's a choice for us to make in the standards process, which way we want to go. So,
Steve, can
yes.
you go back to the previous slide, please?
This one.
Yeah. So
I think you have some. I think you have some illustrations like this, but
yeah. So the thought that occurred to me was there is a direct comparison between this and the previous slide, the ellipsoid one. Although the ellipsoid makes a discrimination between uncertain error, accuracy, whatever you want to call it, in the 3 dimensions. But if you take the simplest case where you have an uncertainty of, say, a meter from your, or a centimeter from your central position, that is a sphere in that picture. And going on to the angular one on the next slide, that has an angular uncertainty, which again is a singular value, which comes back to Gabor's requirements of 5 centimeters or 1 degree. So as a first cut, that seems like a reasonable description. Again, it's something we can modify, and Jim's suggestion is a good one to start with, to say, well, there's an ellipsoid for, because we know that there's different uncertainties in the different dimensions, height particularly, I think, versus the 2 horizontal directions.
yeah, if you look at GPS results, that you have a sort of uniformity horizontally, but less accuracy vertically. So
yeah, and I think that's reflected in the web standards as well, as a horizontal accuracy and a vertical accuracy.
So you could just say it's an triaxial ellipsoid. In other words, an ellipsoid's got 3 different axis lengths, and you draw the circle. Well, you draw the boundary of the area that includes the different possible pointing directions on the surface of that ellipsoid. I mean, that sounds like it's like really nails everything down pretty tightly.
Yeah, and I think the blue circle in that diagram could easily extend to an ellipse, that you have more uncertainty in one direction than another. Okay. If you think of, let's not use a military analogy, a telescope that rotates in the horizontal plane, and then has an elevation as well, and you have 2 motors that do those 2 different things, they might have different accuracies. Those 2 different gearing systems may have 2 different accuracies. So your pointing accuracy is affected by that, to point your telescope at a particular part of the sky.
Yeah.
Okay, thanks.
Thank you. Anything else? Okay, that seemed pretty useful. So that's not really.
Okay, so Jean-Eric's pasting something else. He's got some code. He's
I'm
pasted
not,
in the
I'm not
chat.
monitoring the chat,
Yeah.
so
Yeah,
it
that's
seems
why
like
I'm telling
Christine
you.
is doing that for me, yeah.
Yep.
I could explain if you want to hear
Yes, I
the
think you
idea.
should.
This is just an idea that occurred to me right now. So I was kind of first mentioning that there's an issue now when we have different components that you know, we're talking about uncertainty or you know, time. Those things aren't exactly poses, right? So they're kind of you're starting to model things that are outside the scope of a pose, but they often occur together. And there it would be nice to have like a general interface between such things. So one thing you could do is kind of have a method where you can on the fly just reference the IDs of components, so that you know the specific component that you know some encoding format for, and you refer it. So my idea of how you could do this in JSON form is that you provide an array. The most basic idea is you have a you have a field could call it like basic construct definition or something, and then you give an array of strings. And the first string could say that, okay, in this construct there's going to be a basic quaternion GeoPose, and there's also going to be an OGC basic UTM millisecond time instance, and you could also say you want a positional uncertainty ellipsoid, also defined by OGC. And then there would be some way to know where those encoding formats are specified, so that when you see these strings, then you would know how these components are shaped. And then you provide the next thing that would be not an array, but like an object. Could be an array, but I think object is nicer. Because then you can use the names that you used in the basic constructing for the field name. So you could have a field that's called basic quaternion GeoPose, and then you slot in that, and then you have basic UTC millisecond, then you slot in that, and then you have positional insert. So it's in the chat, the kind of the ID here, but I think that could work. So when you already have that and you have this way to define an array of construct parts, you could call that a template. So you could have a named reusable template that is kind of a basic construct def, but it's given a unique name. So if there's something you often have together, very often you would combine time, GeoPose, and uncertainty, and angular uncertainty, then that would be like a reusable template. So you give that name, and there's like a template authority. So
Yeah, that's a great idea, yeah. I mean, that's part of the
you say that,
motivation
then
in
I have
using components, is to be able to put them together as you need them, as opposed to the way they're given to you.
Just I want to see if I understood correctly. What, Jean-Eric, you're suggesting is, again, it's an external reference to an authority that resolves uh, the the correct system. Isn't that what Steve had proposed with authority in GeoPose 1.0 that was met with some
Well,
consternation?
that was totally handing the problem of what does this mean to this not defined anywhere authority and
Yeah.
multiple
Kicking the can
authorities.
down the road, is that what we call that?
There must be someone out there who might have this name EPSG, let's say, who knows what this number 4326 means, and I'm sure they'll be happy to assist you. So yeah, so I think of that as something different, but I can see if you had if you did have, for example, the JSON schema. So my attempt to use JSON schema, machine readable and computable definitions of these components, using the format property to extend the type of the properties beyond what JSON supports. If that idea can fly, then it can really identify the schema with the name of the object. So position would have, you could resolve that to the schema if you wanted the schema, for example, through some service that doesn't exist. Anyway, that's a good suggestion, Jan Erik, and I think we should follow up on it. Shall I go on to the image? So the title's in the bottom because the top of this thing was all full of information. So the image element components. So these are obviously pretty definitely things that have to do with visual positioning. So you look at the 5 columns here, the leftmost one is a depth map, and the depth map has depth points, and the depth points have color samples, or color and depth samples, actually. The next column, well, it's mislabeled, but it's camera calibration. And that's required to, so this is an interesting topic, and we've had a lot of discussion in the real virtual integration group about the role of camera calibration and the method of camera calibration. So the problem is that if you just get an image, you don't really know the mapping between, or the projection from 3D Cartesian coordinates back to the image plane where the sensor collected the data. You could hope that it was a simple scaling by depth, in other words, a pinhole camera, but it never is, and it can be characterized by different kinds of distortion. So in this model, radial and tangential, but that's again just an approximation. But there's some people believe that it's always going to be possible to get a reasonable estimate of the camera calibration just by understanding and analyzing the image that you're looking at. Other people think that the local device should be in charge of doing that and providing the information. If you look at the what Gabor described, that assumes that the calibration will be provided with the image. So it's an interesting and almost completely tangential to GeoPose core, but super important for visual positioning. The third, volumetric gradient samples. These are just a different representation for the information about the color and the position with respect to the imaging system. Camera pose and scale, well, that's essentially the GeoPose. There is a camera model, but this is assuming, again, that it's been corrected by having calibration information available to make it into a pinhole camera. Targets. So target seems kind of aggressive, but anyway, a
Is it
truck and
targets or anchors?
Or
are they
target.
features?
Well,
Okay.
they're detected features typically.
Why don't we
So you
call
have
them
an
features?
Could call them features. Yeah.
I'm just
Then you
thinking
end up-
about alignment with the, the academic community, the research community, what they call the features in whatever you want, a video or an image or a point cloud. And I mean, and there's a long history of features in OGC as well, I think.
Yeah. Well, I'm thinking, so you have like an image and it's got a bunch of birds in it. And it's got maybe a flock of migrating geese.
Oh,
And
isn't that scene understanding?
well, I mean, scene understanding is the domain that lets you actually find the individual geese and then have a pose for each of the geese with respect to your imaging system. So this is the request we had from, I think, Theodore on range, altitude, and azimuth descriptions of things. That's what it boils down to. So anyway, if you have an image and you're in the image, you can locate in 3D where the geese are. Each goose is a separate feature or target. And the set of all of the features or targets that you detected is the feature or target set. So it's really only a pose, or it's really only a direction and a distance. So it seems like it is like the feature that OGC has permeating its structure, but it's different as well because it's really just like one point. So I don't know. That's my long-winded response to your comment, Christine. Probably not helpful. I don't know.
I don't know.
But
I don't
I
know.
mean, if you look
But
at in this diagram, if you look at target, it's an identified or located object. So let's see, where are they? Yeah, target's probably not a great word, and I'm just concerned that feature might be
too
too
generic.
generic and also tainted with specific applications already. But I don't have a better word. Okay, so
Yeah. Subject, Rob Smyth suggests maybe the word subject. I think the actual label of it comes after understanding how it's used. Coming back to this
yeah,
the use
and
cases.
and actually I'll expand on this just a little bit. So in talking about visual positioning, both Simon and Gabor didn't spend a lot of time on the problem of moving things. I mean, Simon did touch on that, and Gabor touched on it. But so if you're trying to build a model, so in what Gabor described, you build a model of a space, and then you localize images that are presented using that pre-built model, that point cloud. You're matching to the point cloud. If you when you build that point cloud or you build a radiance field model, it doesn't really matter. If you include the instantaneous location of moving things, that's not going to be helpful because it won't be the same from time to time, even between the images that you're using to build your point cloud or radiance field model. So you actually, to make this work well, especially in outdoor scenes with often lots of moving things, you actually need to have a step of recognizing, you have to detect objects and you have to determine whether they're moving or not. And so one of the things that turned up in testbed 19 was exactly this problem. How do you determine if something is moving or you're moving? I mean, it's hard to disentangle the two motions. But one way is to identify a subject or target or feature in a particular image, and then see if it's coherent through time. See if you can find it in the next few images. So if you have something that persists through a number of images, and then you can model its motion with respect to the background, you may understand whether it's a moving thing or not. It's very much central, I think, to making visual positioning robust, is to effectively deal with parts of the environment that are changing. And the changes could also be just changes in appearance as well. So that's well beyond our scope, but I think it's important factor in understanding how to model and how to match and the first step is identifying the obviously moving things and excluding them from your model building. That's my opinion, but I think it's important. So that's another justification. It's not exactly a use case, it's sort of a sub-use case. It's a motivation or justification for tracking things in images because you actually need that to do the visual positioning model building. And this is a structure with a target that's identified as being at a particular time in a particular place, and collected together into a target set that corresponds to all of the different things that I discovered in this image, and which you may want to look at, compare with succeeding or preceding images in order to determine whether this thing is like just staying in one place or moving around. So again, kind of a rambling justification for target beyond just randomly wanting to have targets, but it's actually part of the visual positioning process.
I can see I understand what you're saying. Let me suggest though that there are these layers of abstractions and borders between topics where it's where it makes sense for there to be proprietary things and other places. It's back to what Jen Eric said a little bit ago. What we need to do is define the interfaces, not what goes in them, in my opinion. And if I think there's going to be a ton of ways of finding zones of interest in features, like, I mean, just the first that comes to mind is faces. You're going to, when you're using a VPS, you're going to need to have controls for bystander protection. And that's going to mean you need to gray out or, remove people's personal identifiable information. And so I think there's a lot of research and a lot of innovation that's going to go into this field. And it seems to me to be questionable whether it's all that productive for us to go into that level of detail. And it feels a bit like it's an implementation. It's where people will innovate and create new value because they because they found faces in this really, really efficient algorithm, or they found some other object that is always selected. So it seems to me that the image stuff, definitely. There was a paper that was written a long time ago, maybe 6, 7 years ago, and it's just going to come out like in a couple of months from ISO. And I sent it to you, Steve. I think it's a kind of a primer on VPS, and it has like 7 ideas for where standardization could be helpful. And I don't know. This isn't the time with 3 minutes, 5 minutes left in this workshop, but I just want to sort of express my concern that this level of specificity isn't necessary, in my opinion.
Yes,
Okay.
I would echo that. It comes back to where's the boundary of GeoPose. There are certainly, I think somebody referred to them as interfaces, and I agree. There are lots of interfaces. There are lots of ways that this can be used, but we need to make sure we don't keep stepping over that line or redrawing that line further and further out, because we just end up reinventing the world. The problem that you were describing, Steve, is one I've encountered in testbed 17, which is how to turn a set of detections, radar blips, if you like, into tracked objects. Is that the same object? Is that a moving object? And in that case, we had a moving detector and a moving target. So it was very important to decide what was moving because we were moving and what was moving because it was moving. But it's the same generic problem. And yes, again, we're straying off into another field.
Okay, I think that's a clear message that this is possibly interesting but out of scope, even though you might need to do it for visual positioning.
Yeah, I think that's right. I think
Agreed.
that the important thing is to find, in general, these are, interesting topics, important topics, and people will come up with some pretty cool solutions for addressing them. But I think that getting, like Rob said, our scope is what our scope is. All right, I'm just rambling because it's been a long morning for you,
has,
Steve, and
yeah.
it's a long afternoon for the rest of us. So I suggest that we kind of talk about sort of what are the next steps. What do you see? I want to say one of the next steps is we're going to have a longer one of these sessions in about 4 months. Yeah, this is June 27th. We're aiming for October 27th. I hope that people will still be interested in these topics in October 27th.
Okay, well, I can just say what I'll be doing during the holiday time of the summer, which is wrapping up the radiance field version of the visual positioning prototype, and getting more experience with bits and pieces in action. And so I'll be so I've taken one message of interesting but outside scope for about 6 things. I'll go back through this recording to sort of summarize that after this is wrapped up. And I certainly will have more experience on October 27th than I have now. Are there any other comments, declarations, exhortations?
Thank you. I want to say thank you, Steve. Great job, hard work. Really, really appreciate your contribution, what you're doing for us as a community. Yep. Good leadership.
And look, we're on time. That's
Yeah.
surprises
and we met
me.
some new people. Pedro, we don't know who you are, but Mesh Map, I found you. So let's connect.
Well, with that, I thank you all for participating. I hope to hear from, see, or otherwise interact with you in the future. And I hope we can
Have productive
push-
discussions and push this
forward
forward.
and finish pieces of GeoPose 1.x in the coming months. So thank you.
Great, great job. Thank you, Steve.